Okay, so now we're going to look at an example of a reaction that's not balanced. So the author of our text claims that an unbalanced chemical reaction can often be balanced by a fairly simple approach, such as inspection. And I'm a little bit like I don't really care for this claim, but it's it's true that it can often be done. But we have to establish something that we can do under difficult circumstances with ones that are not balanced and are not easy. Okay, so that's why we're building this tool here. All right. So first of all, let's look at this equation. Is this balanced? Well, I've got a note here saying no, it's not balanced. But let's see why. It's not balanced because let's use the same table. Okay, let's make a list of elements, a list of reactants, a list of products, and is it balanced or not? So first of all, hydrogen. Is hydrogen balanced? So there's a 1 here. Let me go to a red marker here. There's a 1 here, right? Because it's assumed to be 1 if there's nothing. So 1 times 2 is 2, and 1 times 2 is also 2, right? Is that balanced? Yes, it is. So let's move on to the next one. Oxygen, there's a 1 here. 1 times 1 is 1, and 1 times 2 is 2. Is this balanced? No, it's not. Okay. So what are we going to do? You can see that the hydrogens are balanced, but the oxygens are not. To achieve balance, the coefficients of the equation must be changed as needed, right? This is very important for me to emphasize. Subscripts cannot be changed because they change the identity of the substance itself. Water looks like this. Hydrogen peroxide looks like this. They are very different. You cannot change that subscripts, all right, without changing the actual equation or the reaction. So you're not allowed to do that. You'll only change the coefficients. So, all right, so let's look at this. The oxygen atom, if it can be balanced. We had 2, remember that? We had 2, and so if we put a 2 in front of this, then we can get 2 oxygens. And so now this is balanced. So we start over again. Now that I've got that, I say, well, there's a 2 times 2 that gives me 4 hydrogen atoms, and a 1 times 2 gives me 2. So now hydrogen is not balanced, right? So no problem. We'll just keep going. So now we'll just add a 2 to this, right? And can you see that I've got 2 times 2, which gives me 4. 2 times 2, that also gives me 4. So hydrogen's balanced now 2, and oxygen is still balanced. So the coefficients yield equal numbers of both hydrogen and oxygen on the reactant product side. The equation is therefore balanced. So as you can see, I sort of do this in an iterative process, right? I go from left to right, and I just do one element at a time. So hopefully that's helpful. We'll do many, many more of these examples in the future.